Hello, my name is Dr. Ranjiva Munasinghe. I'm assistant professor at the SLIIT Business School, and I'll be making a presentation on our research on the sentiment analysis for Sinhala in social media, a comparison between word and character engrams. Let me give a brief overview of the talk. So in the introduction, I'll talk about our research group, what is sentiment analysis, and the state of social media in Sri Lanka. After that, I will talk about the objectives of our study and then go through the methodology and share results and future work plans. So our group consists of the principal investigator, Professor Samantha Telijagoda, myself, Dr. Ranjiva Munasinghe, as the co-investigator, and we have our research assistant, Pradeep Jayasuriya. We also received an FGSR grant for this work. So sentiment analysis is basically about understanding what is the attitude towards a particular topic according to the language that it is written in. So there's plenty of applications, social media monitoring, brand monitoring, and market research. Hence, we wanted to pursue this area because of the many use cases. For the Sinhala language, the main challenge we face is the availability of resources. So for a language like English, there is WordNet, SentiWordNet, the Python NLTK library, a lot of resources which can be used to analyze the English language. There's also other issues to consider, like the domain, or what, for example, what topic are you talking about? So to analyze posts from, say, a topic like sports differs from an area like politics. Also with social media, you have the divide between the formal and informal languages. And there are many research groups in the various universities in Sri Lanka that are working towards improving the sentiment analysis capabilities in the Sinhala language. So social media is rapidly growing in Sri Lanka. As we can see, Facebook and YouTube usage is reaching 7 million people. So we felt that this is a very relevant area. In particular, we selected YouTube as a social media platform, and we selected the domain of sports. Our data set consisted of over 2,000 posts, and we made sure that there was an equal amount of positive and negatively labeled comments, which we pre-label. And we make this following 75-25 split for the training and the test set. This is a standard methodology for machine learning. So our objectives of this study, we wanted to identify the best classification algorithm for the Sinhala language, for the domain and that we have chosen. We wanted to compare the difference between word and character engram feature extraction. So in particular, we look at the accuracy and also how long the process takes. Some sub-objectives, the domain-specific sentiment analysis, in this case sport, and also collecting specified stop words for the domain. So this is the high-level view of the methodology, where we take comments, we do the tokenization, pre-processing, and then extract the features, which are then input into the algorithms, machine learning algorithms, which then output the sentiment. So text pre-processing, there are three steps. One is the text cleaning, so things like removing non-Sinhala characters, numerical text, and removing punctuation apart from the full stop. So tokenizing, which involves taking a sentence and separating them into the separate words, and also the stop word removal. So words that don't have any sentiment value, like, for example, the, year, may, or in English, for example, and, in, on, they do not contribute to the sentiment prediction. So in terms of the feature extraction, we have what we call word engrams, where we take, if we have a sentence, we take each word, so for word out. So for example, in a unigram, we take each one word. So he is the best player. You have 5 different engrams. He is the best and player. If you consider bigrams, you take the adjacent words and you'd have 4. So you have he is the best and best player. So you can do this for trigrams, 4grams, and so on and so forth. Character engrams, we take the specific characters. So for example, if we are using n equals 3 in this sentence, we could have HE and the space, or E space I, and so on and so forth. So characters, character engrams use the characters including the space. So we also, what we did was we took combinations. So we took the individual character engrams and also the combinations of different engrams. For example, we can consider bigrams and trigrams, 2, 3, and 4 grams, for example, right? And we can take different combinations. And we can also do with the word engrams. We can take unigrams, bigrams, trigrams, or combinations. There's another thing where we can also consider word boundary awareness and adjacent word awareness, right? So we can either consider them only inside the word boundaries, or the engrams that are shared by 2 adjacent words, which is with the adjacent awareness in the engram tokens. Another thing to consider in the Sinhala language is that we have a compound form with the vowel stroke or the pillar. Okay, so that's another thing we have to keep in mind. So the Sinhala letter, you can either have a character unigram or the compound form, which would be a bigram. So this is an overview of how the machine learning works. So you send the pre-labeled data. So in our case, we have pre-assigned the positive and negative sentiment. And then we describe this feature extraction process that is input into the machine learning algorithm. And then that is then fed in to this classifier model. And then the classifier model is used on the test set. So the test set, you have extract the features from the data, and then input that into the model that was established from the training set, and then you try to predict the labels. We used 13 different machine learning algorithms as listed by this slide. And we also use this process of cross-validation and also looked at the performance metrics such as F1 and the accuracy. In terms of our results, we see that the character engrams outperform the word engrams. So for the character engrams, we looked at the individual ones initially against the word engram, the individual and the combinations, and we saw 80% accuracy for the character engrams. And we found that the word engrams are perhaps too strict in collecting evidence from the sentiments. We also looked at this effect of word awareness in character engrams, and we sort of got a counterintuitive result because we felt that we didn't have a large enough corpus. And in terms, when we considered the character engram combinations, we saw that the combination of 3 and 4 engrams give the highest accuracy. And multinomial naive Bayes and complement naive Bayes were the top algorithms. So we can view a chart of these results summarizing the table. And our results, so the character engrams also allow us to overcome spelling mistakes and also function as a stimmer. For future directions, we hope to explore the use of Sinhala syllables as features, and also move on to using ensemble methods to improve the accuracy, and also transition from the machine learning to the neural network framework and use things like deep learning. Thank you very much, and that concludes our presentation. Bye for now. Thank you.